I'm Guilpain from EJR-Quartz for DexROV, and welcome to the DexROV Monitoring and Control Centre in Zaventem in Brussels. I'm here today with Jeremi Gancet, who is our Project Coordination Officer and is also the Technologies, Applications and Research Division Manager for Space Application Services. Hi Jeremi.
Hi Lisa.
And hi everybody who's watching. We're here today at the Space Application Service offices in Zaventem to show you a little bit about the DexROV Monitoring and Controlling Centre. And Jeremi's going to help us explain some of the things that happen here and some of the technologies we've been developing for the project. So tell us about the different technologies working together in the DexROV project, Jeremi.
Right, so in DexROV we want to be able to control robotic systems that we deploy at sea at a far distance from our headquarters here in Zaventem. And this requires, well, first of all, the robotic system to be used in the sea. And in DexROV we have developed really the technologies for doing manipulation and grasping to be able to do some interventions on target system. So it can be either in the domain of energy, that we may want to manipulate some infrastructures to do some maintenance work, or even in archaeology or science domains where there is a need to catch some objects typically. And DexROV, besides these, say, robotic systems in the water to do these operations, also require these control center infrastructures to do the overall control of the robot.
And just a little bit about the project. How long has the project been running now?
So we started a bit more than 3 years ago, in 2015, and we are now very much approaching the end of this project. These are now the results being presented somehow.
And who are the partners and what are their specialities?
So we have a consortium of 7 partners in DexROV. We have a mix of industrial partners and more academic or research partners. And the industrial partners, so besides Space Application Services, who's the partner coordinating the project, we have COMEX in France, which is providing the vessel and the robotic platform on the top of which we attach what we have developed in DexROV.
Yeah.
We have an Italian partner called Gancet doing the development really of the hardware of the system that is to be attached to the robots that is
the
used
Dextrose manipulator.
Absolutely. And besides, we have also academic partners, so universities in Germany. We have Jacobs Bremen, which is supporting all the software dealing with the perception and the modeling of the environment, which is very important for our activities.
And the stereo vision system, right?
This included absolutely a stereo vision system, so 2 cameras attached together, which allows modeling the environment and transferring a 3D model of what is perceived to here to this control center for the operators.
And of course EJR-Quartz.
EJR-Quartz absolutely is a key partner of the project, because this is such a project needs to be very visible, to give a very good say outreach of what is being done, and this is the role of EJR-Quartz. Maybe to finish with a whole set of partners, I see I still missed INEA in Italy, so yes, we have some people in Italy on the academic side also helping with the software for the control of the robotic system, and in Switzerland, EDIAP, who is also helping with artificial intelligence software, which is also very important as part of the overall scheme.
Exactly.
So we made the 2 of the partners.
Of course. So, and hi to all of our partners if you're watching. We hope that you're enjoying the live stream and that you're following along. So, and a question I have here is, Jeremi, what technologies are we developing that are pushing the state of the art in the project? What parts of this are really exciting?
Well, I would say several of them. It's, for instance, quite important for DexROV to be able to develop some capabilities for manipulation in the water that can also have the possibility to feel the forces of what is being touched in the sea, because we need the information here in the control center to figure out let's say how to do very dexterous manipulations without damaging what we are touching, with rendering proper information to the pilot in the control center. That's one of the important points, for instance.
Okay, and other things that we're doing that are state of the art. I believe our perception system is state of the art as well.
Yeah, absolutely. Doing, say, these perception on the sea has a number of challenges to take into account. So we need to have some reliable ways of doing the modeling of the environment, and the camera system that our colleagues from Jacobs are developing helps exactly doing that, acquiring, say, a 3D model that we can rely on from this control center to supervise operations of DexROV.
But of course, for space apps, the most exciting thing is here in the control center, and it's over here to my right, off camera at the moment, is the exoskeleton for the ROV operator. So before we move the camera so that you can see the exoskeleton, what can we see here behind us? We've got a few people from Space Apps here. We might be able to ask them what they're doing.
Sure.
So, Xavier, hello. Hello. So, tell us a little bit about the setup.
Okay, so basically this setup that you see here is the MCC, so the Mission Control Center. From here, we can basically monitor all the mission from Brussels. So as you see right now, it's a video stream of some operations that we did yesterday in Marseille. And from this video stream, we also get telemetry that we can see and observe here. Additionally, we have a HMD that we can put on here when an operator is in the exoskeleton.
Exactly.
And then using this HMD, basically can manipulate objects. You need to wear it, otherwise it becomes black.
Okay, I can't put it over my glasses at the moment.
Or you can put the finger here.
Ah, okay. So this is the Oculus Rift that we're using to generate a virtual reality environment so that the person who is piloting the ROV, and you'll understand when you see the exoskeleton, feels like they're actually almost diving or swimming with DexROV, right?
That's what we try to convey as a feeling for the user.
Exactly. So we've got actually a diver in there, right? Okay, and all the other screens that are going on here, this is all information that helps make decisions about how the ROV is piloted and keeps it safe, right?
Definitely. This is, for example, a very known view where you see exactly where the boat and the ROV is. And then you can get this information more precisely about what is exactly in front of the ROV. So when you see the panel, we can see it here. Right now it's a video, so it's not
nice.
Yes,
this is from the manipulation of the valves that we were doing yesterday in Marseille. Yeah, so we were actually controlling the ROV from here in Zaventem yesterday during an operation in Marseille.
Even this morning, actually.
Even this morning, yeah. Jeremy, tell us a little bit about what was done there.
Yes, we had a special event this morning that was with a group of people we invited purposely to give a demonstration of DexROV, and we have been exactly doing the kind of operations. We're targeting the projects to do manipulation, to show also to interested people from the industry and research what type of results we could obtain in DexROV. So all of that took place really just a few hours ago, and was
we had
really
quite
nice
a few people here, right?
We were quite a bit crowded in this room, I must say, yes.
So it looks quite futuristic, even in such a smallish space. It's not kind of NASA huge, maybe what people are imagining from the movies, but it is really interesting with all the technology here.
Right.
We also have another person hiding in the background here, Pierre.
Hello.
Hi, Pierre.
Hello.
Come over here, actually. Why don't you come in the middle? Tell us a little bit about what you do for DexROV.
So in DexROV, I was responsible for the control of the exoskeleton part. So we have two arm, left and right exoskeletons plus two hands.
Yep.
And my goal was to enable the control with the measurement of the positions, to send the position to control the virtual reality, and then to keep back the force feedback. And feel it during the operation.
That's right, because there's a really critical haptic force feedback element in the exoskeleton, right?
Yes, indeed. The purpose is really that when we interact with the virtual reality in the scene, we can really feel objects and the interaction with the objects, so that we are almost doing ourselves the operation.
Exactly. So if the dexterous gripper were, for example, to grab onto a valve, it cannot press through the valve. The force feedback lets the operator know where the limits are so that none of the equipment gets damaged, which is really important, right, guys?
Yes, indeed. That is the main purpose. Yeah.
Okay. Jeremy,
yes.
So in our successful test that we've been doing, thank you, Pierre. In our successful test that we've been doing in the last week, can you tell us a little bit about the kind of activities and manipulation tasks we've been trying to achieve here?
Right. So we could indeed manage to get very nice results over the last past days. In particular, we were considering the target panel that is used in DexROV to
the test bed, right? Our three-sided panel
test bed mock-up that is supporting the execution of tests.
There are detailed pictures of the mock-up on our Flickr channels if you'd like to have a more close-up view, and I think on our other social media channels, in our video, in our image albums, you'll be able to see close-up images of the test bed and the kind of tasks that the ROV is being asked to perform. And
this test panel was really the baseline to carry out a number of tasks to validate the results of the project. And yesterday, in this morning in particular, we have shown that we could do very fine manipulation of a couple of valves which are very meaningful for the industry, for the energy industry in particular, and turning them and controlling the way to turn them from here, from Zaventem. And so through a satellite link, we're able to supervise all these operations and to carry out really in a repeatable and confident manner this rotation with the manipulators of the ROV. We are really happy to see that not only working well but being very repeatable also, and so with good confidence.
It's no small task, right, to put a satellite receiver, a big satellite receiver on a ship and to control from there, right? It's quite a big and demanding element of the...
There are parts of that deals with really the hardware, also mounting a dish, an antenna. We have the dish that is on the vessel, to give you an idea, is about 1 meter diameter.
It's quite big, yeah. That's the Omni-Access Sailor receiver, right?
Absolutely. And this allows establishing a link through satellite, which is still with quite limited bandwidth. Even if it's a large antenna, it's certainly not what everyone has at home, like a really fast link. It's a very slow link, as we could have maybe 10 or 15 years ago. And we have to pass a lot of information back and forth through this channel. So this is a challenge.
I've had a few people ask me when I talk about DexROV if we need to book a satellite or anything like this in terms of real sort of space mission stuff. It's in the same vein as space missions, but we don't have to book satellite time or any passes with ground stations, do we? It's not that scale of satellite communications.
If we have a mission to space, there is a special network of satellites, which are with the space agencies, that helps sending the commands and receiving the information, the pictures from spacecraft. But this is very peculiar links which are used in that case, not the regular satellites that are around the Earth for other purposes, like calling or like using internet. Indeed, this is different. But otherwise, it's still very much close. This is very interesting to figure out how close are the operations of spacecrafts and what these kind of setups here in DexROV allows to do. There's already a very nice parallel between the two domains, actually.
Yeah, because this is somewhat similar in terms of what we do with latency, right? So we have several partners working on specific elements that help us to keep going in occasions of latency.
Yes.
And latency, for anybody who's not familiar with the term, is when there's any kind of break in the satellite communications, because it is a very fine element. It's a very fine and not the same as making a phone call. It's a different kind of operation. So there can be small breaks. What kind of time are we talking about in terms of latency? How small are the breaks?
So imagine that the signal has to travel from the control center in Zaventem to a satellite which is located at 40,000 kilometers distance in space, in the sky. And then coming back to the vessel at sea in the Mediterranean Sea at some distance from here, and this takes times even for light or for the waves to be sent. And all in all, this latency indeed might be in the range. So in the best cases, would be in the range of say half a second to 1 second. But quite often, this is even much more than that. Because there are some, part of the signal that may be slowed down when it is processed on one end, and we reach easily 1, 2 seconds, sometimes even more, 4, 5 seconds. So this latency doesn't allow doing really the type of operations that people would expect, say, in a regular way to do to control the robots. You have to imagine new schemes, and this is what we have been trying to do in DexROV.
Yeah, so we have in the DexROV system, we account for that, right, by having DexROV able to, if the connection is even for a millisecond broken in latency, or in worst case scenario, a couple of seconds, it can stabilize itself and even continue with the most logical action, right?
Exactly. This requires you have a certain amount of autonomy on board the robot in Marseille, where we have our platform. So the partners, a couple of partners work really on developing the software allowing the robot to be able to process the data to create the task and to execute this task in the local environment, even if the link is cut, and to ensure that everything will be happening safely and without having the manipulator crashing into an important part of a target.
Yeah, that's really important. So if anybody's watching at home and has any questions about what we're talking about, please feel free to post those either on our Facebook page, which is DexROV, or via Twitter @DexROV, or there is a chat available on the sidebar on the YouTube stream. So if you'd like to ask us a question, we have people collecting the questions for us, and we'll go to a short intermission soon and have a look at those if there are any questions that people are asking. So Jeremi, it might be interesting for people to know, what do the screens here do, and to give a bit more detailed picture of the kind of level of information that's being collected and processed here in the control center. So maybe you could talk about, or Xavier, would you like to talk about what exactly we see here on the smaller screens?
Okay, do you want me each screen by each screen?
That might be nice.
Focusing on one or two of them that are interesting maybe to show.
The interesting ones is basically when we have a task, we know, imagine you have a shipwreck at the bottom of the ocean.
Yeah.
Usually what you get is the GPS coordinates of the shipwreck.
Yeah.
So the first thing is to send the ROV to the shipwreck. To do that, we use this interface where we actually just click and imagine you get GPS coordinates, you plot a course. Once you're happy with the course, you can visualize here. This is a longitude, latitude, depth.
Yeah.
Forget to put the depth. Once you have what you want, you send this information and the ROV will go exactly there. This is taxi, so basically it's to go to a place not super precise, but within the boundaries of what you're looking for.
But DexROV itself is not an AUV at this stage, so he's not going to exactly leave the Marseille harbour by himself. At the moment, he travels with the Janus 2 from COMEX, and our partners COMEX are specialists in ROV operations and lots of other things, including pressure testing and space activities. They do a lot of different things. So in terms of the location, this is for when the ship is already in the area, right?
Exactly.
Right.
You still have umbilical, so it's a rope from the ship to the ROV, which is about 100 meters, 150. Basically, you still need to put the ship on top of what you want to see, but sometimes you cannot come close enough with the ship, and so you still have to maneuver a bit the ROV towards your target, and this is a way to send autonomously the ROV to the target, saying, please ROV, go at that location. Then as soon as you arrive,
becoming finer and finer and finer. The ship goes to the area and then the ROV gets to the exact location.
Very close to the target, and then you switch to another control mode.
Exactly.
Right?
So once you're closed, you don't use a Google Maps style approach. You go for this view. Normally, as soon as you see something, you should get something on the camera feed, and you will get it here on the telemetry, and then you can use this screen to navigate.
So if you can't see in fine enough detail, what I have in front of me on a very nice big TV screen is a 3D model of the test bed and the Dextrose gripper, right? Yes. That's a gripper I can see in front of me. So it's a 3D model. It's got some light and shading features, although regardless of the lighting conditions,
so
right?
This is a replica of the panel that we have at the sea in Marseille. It's also a replica of the ROV, so basically you can see the state. Right now I'm showing a video where we stored the values of yesterday's test, so I can replay it, and then you will see it moves. As soon as I play it, normally it moves, so now it doesn't move, voila. And you can see it's very slow because actions are slow, but actually it moves. And I can stop it. But normally in real life, you see here the telemetry, what is the position, what is the orientation, the tilt of the ROV and everything. And so what you get is basically what you see.
So it might have been a little too slow to catch there if you're watching at home, but the ROV operations are usually done very carefully and very slowly, particularly because we're in a test phase at the moment. So it's not quite what you might see in a Hollywood movie where the robot's going zzz and just turning straight away. We're actually having a much more careful approach at this time because this is still a test phase for the project. The project is really a high-risk, high-reward situation, right?
Of course. These projects are R&D projects, first of all, so we want really to get technologies that we can mature to a point where we can then have maybe some commercial opportunities to exploit the results. But this is not the very immediate objective and possibilities quite often. Still, a number of things in the project are really promising and have some potential for moving to the next steps, and we are really looking forward to that moment where we can get these technologies really used.
So at this stage, no questions have come in from the audience.
Okay.
And what we might do is just take a short intermission, and we'll get our helper here, Mario. We might take a short intermission so that we can show you guys the exoskeleton. We'll be back in about 5 minutes. Thanks for staying with us for the short intermission so we could get the exoskeleton in view. This is probably what everybody's more excited to see. We posted a short video not that long ago on our Facebook channel, so if you're not getting the angle you'd like to see, or you'd like to see more detail on the movement, I need to move over a little bit. Sorry, everybody. Then you can check it out on our Facebook page and you can see the full range of movement. But for now, I'll go over to Pierre, who can start to move it around a little bit and tell us a little bit about what this does and what the aspects of the exoskeleton does. So Pierre, you've got this really cool looking arm, which I had the prototype a couple of years ago for my Twitter profile pic. Still using that. Tell us a little bit about it.
So here we have the right arm that is equipped with a full arm exoskeleton from the shoulder to the wrist. So we have a 7 degrees of freedom. So if we can move like this, we can move the shoulder in all direction, the elbow, and then also the wrist. And at the end we have an exoskeleton hand with one exoskeleton per finger, so we can really move individually all the fingers of the exoskeleton.
So you've got 5 fingers there,
yes,
right?
Well, from the thumb and to the pinky. Yeah.
So there's quite a bit of software wizardry going on to take those 5 fingers and turn it into the 3 fingers of the gripper, right?
It requires some matching indeed between the two sides. We wanted to have a hand exoskeleton that could adapt to a variety of effectors at the end of the robot, and this is why we didn't make just a direct 3 fingers. It is just ready for any type of new devices that we may come to control in the future.
It's quite a versatile result. So here this is some really interesting detail that I'm not sure how well you can see on the screen, but there is little robots in the fingers, little engines, I mean.
LEDs.
Not just LEDs, but you've also got
actuators.
Robotic motors is the word I'm looking for. How's that for stumbling on your words? Okay, so you've got motors in the hands. Tell me about the motors in the hands.
So the motors in the hands are used for 2 purposes. First, the motors are equipped with a small sensor, to measure the position. So when I move the finger like this, the motor is turning, and I can measure the rotation and convert that in the motion of the finger. That we can send to control the virtual reality mannequin to move his hand.
Okay.
And then the second purpose is that the actuator can create a force feedback. So when I'm touching something in the virtual reality, or if the robot, if you control directly the robot is touching something, we can perform force feedback. So we send back the information of the force to block the finger of the user.
So that literally means if the ROV is touching something that you cannot physically push further, the little motors in the hand are going to make sure that that is just not possible. That makes sure that nothing gets broken.
Exactly.
And you've got LEDs everywhere. Are they giving you information?
So the LEDs are there to add an additional information for the operator. And we can imagine any kind of things, such that here, for instance, when we have a contact, they will go from blue to red depending on the magnitude, the force that we apply. So for instance, here, I don't know if you are able to see it, but I am interacting with the virtual reality we have here, and if I press in the virtual reality, I'm changing the color of the LEDs. And here is when I feel something inside.
Interacting with the sphere.
Yeah. So I don't know if you see the screen there, we have a sphere, and when I approach it with all the different fingers, I can have a contact and feel the shape. Also, if I follow the sphere like this, I can feel the shape of it.
Yeah, so it's hard for people to imagine, but you can feel as if something is in your hands.
We have the force feedback on the finger, but also on the exoskeleton arm. So also my wrist, my elbow, and my shoulder are blocked. I cannot go on the left. Yeah, it's really blocking me. If I remove the actuation, I do that. If I press to enable the actuation, I'm blocked. And then I feel the contact.
So the end result is going to be an experience for an ROV pilot where they are going to really feel as if they're working with their hands. So there's a lot of opportunities for different kinds of piloting and opening up the experience for a lot of different kinds of people to do this, right?
Yes, this is to really provide this telepresence feeling. Ideally, we would like to give the impression to the ROV pilot that he is himself a diver directly doing the interventions. And this is really what these technologies are developed for. And we really hope it could be a complete change of paradigm of doing very dexterous manipulation actions. And being able to do that very deeply in the water, not only on the shallow water where the divers go usually, but thanks to the robotic technologies, being able to go 1,000 meters and more to do the same kind of operations.
So, Jeremi, we've actually had a couple of questions come in. So, somebody has written, "Hi Lisa, can DexROV retrieve things from the seabed?" So, can it, guys? I put it to you.
Yeah. Well, the robotic system that we have attached to the robot of COMEX is equipped with sensors that allows perceiving what is on the seabed, perceiving what is in front, and doing a model out of it. So really making like a 3D say reconstruction of what is being perceived. And that information is passed to here, to this control center.
Yeah.
And this is where people can choose or say decide what to do with it. Either it is something of interest and we may want indeed to try attempting a manipulation, or it doesn't seem of particular interest and we just probably disregard it and continue doing the operation somewhere else, basically.
So realistically, we have the potential to retrieve things from the seabed depending on their size and depending on their exact location, but at this stage we're not really ready to go out diving for lost things quite yet.
There are a number of constraints, but this, let's say the orientation of the perception system is very important to figure out what we can see. For now it was done and prepared in such a way to be able to see more like artificial structures for which we may have even a model we can use. If we have to go already in a place we never visited before, we may need to change a little bit the way the perception system is attached to the robot to be able to really see well what is on the sea floor. So it would be definitely possible, but not exactly with the setup which is configured for now.
Okay, so how many people does it take to operate DexROV is another question we got, and so what is the minimum crew?
That's
this is an interesting question.
Indeed.
I think
the ideal, perfect, and minimum crew would be probably one person on board the vessel, because we need always still, for now, having someone that can, first of all, be there as a backup and take the hand is ready something was to go wrong for some reasons.
Yep.
And also to do the maintenance of the robot itself, because having a completely autonomous ship with a robot that would deploy may possibly happening in the future, but for now, every time a robot is going at sea and comes back, most of the time there is a number of things to say, to address, to fix, to check before sending it again. So this requires having maybe at least one or a couple of guys still on board, ready to help with this for the time being.
But it is a reduction in crew. So
this is definitely a reduction in crew. Yeah.
How long? Another question is, how long can DexROV stay underwater?
This is, let's say there is no major constraints added by DexROV on top of what is usually done.
So I guess until the remote operator wants to go home for dinner, right?
Correct, but then there could even be a very quick shift of people that would be behind the exoskeleton. And this is a way actually it works for now. People are staying for 12 hours in a row at sea, say controlling, piloting ROV. So these underwater robots, and then someone else replace that person, and that can go for a number of shifts this way for days of operations. It's not just a couple of hours; could be several days or even more of operations.
My hat goes off to those guys. I was out on the ship with the consortium as a communications officer. It's tough out at sea. It's really tough to be working round the clock in these kind of conditions. So it is a big boon to be able to bring people home and to be able to set this up anywhere, right? Because this could be set up anywhere.
And this means the same pilot that would be otherwise offshore can indeed do the same type of work, but from the onshore control station, and somehow having more comfort to do that, less risk also, because each time people have to be going far at sea. This is with a copter to say maybe a location which might be hazardous also, right? Having some hazards, and say these risks and the quality of life over there is very different from what you can get, of course, here on the control center. Yeah.
So another question, it might be our last question if I can just confirm, is what's the maximum latency operators can work with in the current configuration?
So the good thing with DexROV is that we have a system that typically is developed and designed with the idea that we can deal with very wide range of latency. It could be from very, say, small, almost no latency at all, and it would still be possible to use the system, up to several seconds or even minutes of latency, and maybe why not even more, as long as there is still the system running properly on the offshore side, even if the satellite link is cut, we can still expect the robots to behave in a consistent manner for a period of time.
Okay, so there is almost no upper limit of latency if the system is functioning as it's expected to, with the understanding that this kind of technology can be a bit tricky, but there is no upper limit constraint because it does have that autonomous capability.
Exactly. At some moment of time, probably the robot would just put itself in standby mode if it doesn't receive more commands or requests, but we could expect that it would behave safely if there is really a very long communication cut for whatever reasons. Okay,
well, that's no more questions from everybody out there. Thank you so much for watching today. Thank you, Jeremi. Thank you, Xavier. Thank you, Pierre. That's all from us today for DexROV. Signing off from the Remote Control and Monitoring Center.